This is some notes on how to make 2D arrays. I'm going to try to show how to make one-dimensional arrays or just review that. So here's a one-dimensional array right here where we made an array called dogs that was size 5. It's an empty one. This is using an initializer list to make an array. And this is the famous for loop that we all know to loop through an array. This time I'm looping through ages to print out everything in ages. So that would just print 1, 2, and 5 to the screen. So this is stuff we've done before, but now how can we apply this to a two-dimensional array? So let's check that out. First thing, to make a two-dimensional array, it's int square bracket square bracket. So that is saying, oh, now it's now going to be a two-dimensional array. I'll call this table. It doesn't matter what it's called. It could be dogs or ages or scores or whatever. We'll just call it table. Equals new. Notice it's very, very similar to how to build a normal one. And then if it's an int, remember, it doesn't have to be an int. It could be a string two-dimensional array or even an object two-dimensional array, such as an array of cards or an array of bank accounts like we have done before. So this is the type of array. The only difference is now it's a two-dimensional array. So the same thing over here, you have to declare the size when making a two-dimensional array. So it should be a square bracket. And let's suppose we're making a 2 by 3. But if we put, I'm having some problems here. If we put 2, 3 there, what does that actually look like? So over here on this side, I'm going to try to show a picture of what we just made. We made a remote control called table that points at an object, and that object is a two-dimensional array. It's a 2 by 3, which means the first number that you put is the number of rows. So there are 2 rows and there are 3 columns. Okay. Now they're all blank right now, so if I put zeros in all those spots. But if I wanted to reference those spots, what's going on? Each one of these has a reference. So what is the name of this cell? Well, a one-dimensional array, if you remember. So that first one that I built of size 5, which was dogs. So dogs was an array that had 5 spots in it. This is horrible, but this first spot is the 0 spot, and then the 1 spot, and then the 2 spot, and the 3 spot, and the 4 spot. So if the length is 5, the last index is 4. So, how would I get to this spot right here? Well, this is row 0, this is row 1, this is column 0, column 1, and column 2. So this spot right here would be row 1, column 1. This spot right here would be row 1, column 2. So let's suppose we wanted to put a 7 right there. If we wanted to put a 7 in that spot, how would I do that? So we'll come back over here and say, okay, I'll take table in row 1, column 2. That spot, I want to put a 7 in there. So that's equivalent to putting, if I came back over here now and put a 7 in there, I just put a 7 in that spot right there. So first the row number, then the column number, but remember they start indexing at 0. So this first spot right here, the very first spot is 0, 0. So if I wanted to put like a 12 in the first spot, it'd be table square bracket 0, square bracket 0 equals 12. So you can put thing in any spots very easily that way. Now, just like if you wanted to know the length of the array, up here we have this thing called ages.length. Ages.length tells you how big the array is. Well, the problem is here we have 2 different dimensions. So there's a variable to keep track of the number of rows and a variable to keep track of the number of columns. If I did table.length and just went like that, this gives you the number of rows. But what if I wanted to get the number of columns? I would say table. It's kind of fun, table, and it doesn't really matter what row you pick because each row has the same number of columns, but you really say go to any row, like table 0 we'll say, that's a row, and get the length of that row. Now there is such a thing, and you can read in the book on this, this is the number of columns, as a ragged array where each row does not necessarily have to have the same number of columns, and that is possible. So maybe table 0.length is not the same thing as table 1.length if row 1 does not have the same number of elements in it. But that gets a little bit trickier on how to build a ragged array. We'll just deal with rectangular arrays. So we don't have to worry about that ragged thing. All right, how do I now print? Well, maybe we want to store this into, we'll just Well, what if I always wanted to get the last spot? That's a good test question. How would I put, you know, we put a 7 in the last spot, but we knew the dimensions. What if we stored this into a variable, and we call this rows, and we store this into a variable, and we call this columns. So now rows is storing the number of rows, columns is storing the number of columns. Instead of me putting table 1, 2 equals 7, which was the last spot, what if I did not know the number of rows in the columns of the array itself? How could I put something in that very last spot? So I would say table, square bracket. And I don't know the number of rows, but I do know there's a variable here that keeps track of the number of rows. So I could put table.length, which I've already done, stored into a variable called rows here. So I do rows, but that's going to be too much. So I have to do rows minus 1, because remember, the number of rows is 1 more than the last index of the number of rows. And then another square bracket, and to put it in the last column, I would do the number of columns minus 1 as well to get that last index, and then maybe I want to put the number 100 in there. So this is using variables to get, this will always give you the last one. Now, instead of me storing it into rows, I could have put table.length in here. So if I, instead of me storing into rows, maybe I do table.length minus 1 right there, and the same thing here. And then again, this table 0 is really, as long as it's a square bracket, it doesn't matter if this is 0 or 1, because they both have the same number of columns in them. So that's just, so when you see that, you're not completely confused by what's going on there. This gives you the number of columns, this gives you the number of rows. All right, let's print this thing out. We have a nice little for loop up there that prints through a one-dimensional array, but let's now print through a two-dimensional array. So we'll set for int I equals 0. As long as I is less than, it's going to look the same, table.length. Now when I put table.length there, I'm looping through the rows. This is a loop that will loop through each row, and I'll do I++. So if you want to put a comment there, this loops through the rows. But this is the first time that we're going to use a really cool inner loop. Okay, I'll start a sexy brace, end a sexy brace for that loop. But then inside that loop, I'm going to start another for loop. And I'm going to pick a different variable this time. I'm going to pick, let's say, j. I'll start j equaling 0. And this is common variables that are used. As long as j is less than, now this wants to loop through each column. If I want to loop through each column now, I have to take the row that I'm in, which is table I. Table I is the row, and I want to find the length of that row. Now, if this was a ragged array, this would still work because, you know, the first row, first time through this outer loop, I would be 0, and it would get the length of the first row. And then I would be 1, it would get the length of the second row. So this could change, but in our case, it really doesn't matter what I is in this case, but it is nice to know. But now we're looping through the columns, and this would be j++. So this loops through the columns. All right, but then we have to start a sexy brace, end a sexy brace for that as well. All right, then what do we want to do here? We want to print them, so we say system.out.println, and what are we going to print? We're going to print out table square bracket I square bracket j. Like, this is a very famous a loop. You may want to pause it and copy this down if you don't understand it, and you can come back to it and revisit it. It's also in the book as well. It's a famous loop of what we'll go through, and this would print them all out. Like, if you actually wanted to see the table, we would have to print this instead of print line. Remember, print puts them, but now all the numbers would be next to each other. So after we print it, we would concatenate that with a tab, with a \t inside of double quotes, and it would keep printing it over every time. And then so this loop right here loops through one row. So that would take this row over here and just loop through it and print out, in this case, the zeros. But then if I wanted to go to and then it would go back up, change I, so then it would print out the second row. But if I wanted to like have a new line between there, this is just formatting the output. This would say system.out.println with nothing there. And all this does is make it go to the next line. We're just formatting output now. The key thing is realize that to traverse through a two-dimensional array, you have to loop through the rows and loop through the columns. Now I'm printing them, but maybe we want to add up all the numbers in there, or maybe we want to check how many of the names. Maybe it's a string double array and we want to check how many of them start with the letter P. We can do anything we want in this section right here. Here I'm just printing them, and then I'm trying to make it fancy by printing, tabbing over, and then going to a new line. This will make it actually look like a matrix when we're done. So if I run this real quick, see if you can see this. Oops, I did a /T instead of a /T. That didn't work out so good. Nobody in class was able to stop me because you're not really here. This needed to be a /T. Maybe some of you were yelling at me as I was doing it. It didn't work out because I could not hear you. Let's try this again. So if you notice, I did put some numbers in there, so they're not all zeros, but here's the first time through the inner loop, and here's the second time through the inner loop, and I just printed them. This 1, 2, 5 is printing the original array, but there's that, kind of looks like a table now, which is kind of nice as well. But the main thing is just understanding how to loop through a two-dimensional array, how to build a two-dimensional array, how to loop through one. The last thing I'm going to do is just show you how to build a initializer list. If you already know the numbers that are supposed to go in there, how does an initializer list look like? Well, here's the initializer list for a one-dimensional array. What does the two-dimensional array look like? So let's do that again. We'll say int square bracket, we'll call this, I don't know, scores, equals, and we're going to start that curly brace or sexy brace to say, okay, we're starting a two-dimensional matrix or two-dimensional array, and then we start another sexy brace right away to say this is the first row. And let's suppose in the first row we wanted the numbers 1, 2, and 3. And then we end it. So that little block of code right there is the first row of the matrix, or of the 2D array. I keep saying matrix. But that's the first row. And then comma. And then I'd start another curly brace saying, now I want to start the second row, and let's suppose this had the numbers 4, 5, and 6 in it. And then I would end it. So now that little block of code is the second row of the matrix. And if I wanted a third row, I'd put comma, and I'd put another row here. Let's say we have a 4 or whatever. I just keep going in order, 7, 8, and 9. So you separate items with commas, and you separate rows with the curly braces. And then if you're done, actually this one's not very good. I better do one more so you can see that it's... so we just keep adding rows, and then when we're done, we would end the section brace, say I'm done with the entire, and then put that semicolon. So if you wanted to see what this looked like, how many rows and how many columns are there, looks like there's 1, 2, 3, 4 rows, and each row has 3 elements in it, so there's 3 columns. So this should be a 4 by 3, so it's equivalent to making a 4 by 3 two-dimensional array, but instead of me having to build it and then put all the numbers in, if I know the numbers that are going to go in there, I can just use this, which is an initializer list. But make sure you know the syntax for that if you're ever asked to do that on a test. Again, I would strongly suggest you pause this and write that down. But let's see what that looks like, just so you know. I'm going to take this loop, copy it and paste it here, and then just change a few things. This isn't table anymore. This is scores, and this would be scores as well. This would be scores as well. And then I think everything else there is okay. It says we're good. So if we go to run this thing now, better get rid of that background. What does that look like? So notice it did have 4 rows and 3 columns. 1, 2, 3, 4. Here's the 4 rows. So that other stuff was oops, a little bit high, but there's our array right there. It had 4 rows and 3 columns to it. So make sure you know how to use an initializer list to put them together as well. So that's 2D arrays. There is no specific programming assignment on it, but you should be able to complete the back of that worksheet that I gave you before break. Now using those 2D arrays, try to finish that worksheet on that. If you have any questions, make sure you let me know.